So I'm writing the integral in its simplified form. So we have this I integral equal to 2 over a squared r, and then minus e to the power minus r over a, and the first integral goes from 0 to infinity, and r plus a, r plus a, and e to the power minus 2r over a r dr, and then plus e to the power plus r over a, an integral from r to infinity, and r minus r plus a, e to the power minus 2r over a, and r dr, and plus e to the power minus r over a, 0 to r, and r minus r plus a, and we don't have e to the power minus 2r over a here, but r dr here, and we will have to close the bracket here. Now if I look here, this integral, we have two integrals here, like one is r square is coming with e to the power this. The next will be r with r. So the next integral is basically r e to the power this. And then the next will be only a and this with r this again. So the second and third are basically with r, while the first integral is with r squared. Now for the r e to the power minus x, or the e to the power bx, we have written the formula, while for the r square I will write the formula here, that this formula is equal to, when we are having x square e bx, like when it is x square e to the power bx and dx, and we are integrating such integral, then this is equal to e to the power bx and x square over b, minus 2x over b square plus 2 over b cube. So this integral solution according to this identity is like this. So now think how many integrals do we have here. One with r squared and e to the power this. The next is with r and r e to the power this. The next will be with a, r, and this. R, we can add up these two, like r square with this e to the power minus 2ra, and then r plus a and r dr in with this e to the power. So because r and a are both constant here, so we will have to solve these integrals. Now in the lecture notes you will find a step-by-step solution to this, but this integral comes out as I have solved this one. This comes out to be a cube over 2. A cube over 2. By putting the limits, we will get finally this solution plus a square over 4, and r will come here with this. So I solve this one step by step, and then I solve the next integral step by step, means this integral step by step, and its solution came out to be 3a square over 4r and plus a cube over 2 plus e cube over 2, and this whole is being multiplied with e to the power minus 2 r over a. This is the solution of the second integral, while the third integral, this one, is having the solution after step by steps solving this thing, 1 over 6 r cube plus a over 2r square plus a over 2r squared. So these are the three solutions here, and we will have to put the three solutions, and then we will have to simplify this. So the integral solution is this multiplied with this, and then the integral solution is this and multiplied with this, and similarly the third one. So after putting all these and simplifying, we will get that the integral I comes out to be the overlapping integral e to the power minus r over a and 1 plus r over a and plus 1 over 3 r over a whole squared. So this is the final solution of the integral, and I have solved this one step by step, means all the simplification. So when you are having the lecture notes, then you will have all those steps. It is needless to write all those steps here because this will make our lecture much lengthier. Okay, and now if we put this integral back into the original integral, which was our first equation, equation number 1, then we will have, now here recall a little bit that what was basically this thing. This integral was the overlapping integral in which psi naught and psi naught r1 and psi naught r2 were interacting with each other. Now we got the solution of that integral, and the solution now tells us that this equation, this overlap integral, means the interaction of two wave functions, this goes to 1, like I goes to 1 when r goes to 0. Because when r goes to 0, then we have 1 here, we have 0, 0 here, and then it goes to 1 here. And what when r goes to infinity? When r goes to infinity, then where this one is going, because when this goes to infinity, then consider this term. This is 1 over e to the power r, so 1 over infinity it will go, I will go to 0. So remember, I have erased the figure here, but now the interaction part is very clear. What was R? What the R was basically the spacing between the two protons. So when the spacing between the two protons goes to zero, like the protons are coming closer to each other, then the overlap goes to 1. It goes to the maximum because this is the overlap integral. If you remember the previous equation, then in the normalization, the psi mod square was equal to 1 for R1, psi mod of R2 square was equal to 1. So this term also goes to 1 when R goes to 0. They are the overlap integrals. I mean, the two wave functions are basically overlapping each other. Now in that wave function, when R goes to 0, like you are bringing the two protons closer, then their waves will just behave like the other, like a single wave, and then this goes to 1. While when R goes to infinity, the two protons are farther apart from each other, then the two waves are actually not overlapping at all. So the interaction or the overlapping term goes to 0. So this is the concept behind this overlapping term. The rest are just the calculations. So putting the value of this I back into equation 1, we have, you remember that we were having equation 1 equal to A mod square, and then we were having for psi naught R1 mod square, the value is 1. For the psi naught R2 mod square is 1, and then 2 times the overlap integral, which is the I integral. So from here I can find out the normalization constant. Now what it will be? 2 plus 2i. So you take 2 is common, then you are having 1 plus I with this 2 here. So I can write that A mod square is equal to 1 over 2 1 plus I. So this is the normalization constant in terms of the overlap integral I. Now when we are done with this, then we will have to go back to our previous equations that we wrote for the energy, and that is that the expectation value of H. Now as we have determined the normalization constant in terms of I, our next task is to determine the expectation value of H. The expectation value of H we will have to determine, and we know few things here, that minus for first proton in electron interaction, we have minus h bar square over 2m del square and minus e square over 4 pi epsilon naught, and when this is applied on psi naught R1, this is equal to E1, the energy is E1 and R1 here. So psi naught R1 here. Similarly, we have minus h bar square over 2m del square minus e square over 4 pi epsilon naught for the other proton in the electron interaction. This is psi naught R2. We have energy is the same, E1. E1 in both cases the same, psi naught R2. So having this thing in mind, we know that psi naught R1 the ground state energy, the ground state wave function, while E1 is the ground state energy of a neutral hydrogen atom, which is minus 13.6 electron volt, as we know from our previous knowledge. So we have to calculate the value of H here. So doing this thing, but now we will not take individual wave functions, we will take their linear combination as we did in the previous overlapping case. So I can write that H will be equal to psi H psi, where psi is basically the linear combination of the two. So I can write that this is equal to A and psi naught, and then H. I will write A and then psi naught R1 plus psi naught R2, and this is being multiplied here is the Hamiltonian, and then again we have A and then psi naught R1 plus psi naught R2, and the bracket is closed here and here as well, and we have this H. So use the bracket notation here. This is the expectation value of H, and now take this thing out. The A conjugate will come out from here, and from here A will come out, and then we will have to write the individual terms. So what the individual terms will be, let me write those terms as well. So we have, when A is out of here, then we have this is psi naught R1 plus psi naught R2, and then we have H, and then again psi naught R1 plus psi naught R2. So this is the bracket notation here, and this is here, so we have parenthesis here as well. Now what we will do here, like this H will operate on psi naught R1, then this H will operate on psi naught R2. So what we will have in both the situation, we will have, when this H will operate here, we will have E1. So E1 I can take is common, and then the rest I can write that when this will be operated, we have the Hamiltonian, this equal to A, and this will become mod square, and then even the eigenvalue means here will be even and here will be even, so we have the E1 here common from there, and then I will write rest of the equation, and the rest of the equation is psi naught R1 plus psi naught R2, and then we have to multiply it with psi naught R1 and plus psi naught R2, and here. So the H has done its part with this.